This video is about the learning mechanism of bridges. As mentioned in other contexts as well, today we mainly find switches. However, this method has already been used in the times of bridges. Therefore, I'm talking about bridges throughout this video. As you will see, a bridge automatically learns which devices are attached to it. It is not necessary to configure this on the bridge. On this slide, you see a small example network where a bridge connects two network segments. Inside of the bridge, we find the so-called bridge table or MAC address table. Using the frames that it receives, the bridge learns which devices are connected to which ports. In more details, it learns the source MAC addresses from the Ethernet frames. Timestamps are used to take care that the entries are not too old. If entries are not renewed from time to time, then they are deleted. This keeps the bridge table relatively small and avoids wrong entries. On this slide, we see how the bridge table is filled. There is at first a frame sent by the device whose MAC address consists of 12 Cs. For simplicity, I will just call it C in the following. So the MAC address of C can be recorded together with port 2 and the timestamp. Afterwards, another frame from source B is received and it is learned that B is reachable via port 1. On the slide, you see another term which is called flooding. Flooding means that a bridge sends a frame on all other ports except of the input port. This is done if the bridge does not know where the destination is or in case of broadcasts. On the next slide, we take a look on how the bridge table is being used. The bridge receives a frame with the destination B on port 2. It identifies that the device is connected to port 1 and forwards the frame to this network segment. If there were more than 2 ports, this would already make a difference in comparison to flooding. Now a frame is received on port 1 with the destination B. The bridge deletes this frame, which may be surprising for you. Has this frame reached its destination? When we take a look at the network and try to figure out where the frame came from, we see that the source must have been the computer on the left-hand side. On transmission in the bus segment X, it had already reached the destination B before arriving at the bridge. In this scenario, which is called filtering, you can see a big advantage of bridges and switches. At the same time, another communication on the right-hand side network has been possible. Therefore, bridges and switches allow for parallel communication.